Good evening, everyone. We are Team TechScrum, and today we are excited to present the final demo of our PC project. My name is Kevin, and I will be presenting alongside with my teammate Shelton. We are also supported by our project supervisor, Kitman. Thank you for taking the time to be here. Let's get started. So this is the table of content we are going to go through today. First, we will start with the project background, where we will outline the pain point identified at the beginning of this iteration, as well as the project goals that were set in response. Next, we will go through the core features delivered in this iteration, along with demos. We will also cover some of the key optimizations and bug fixes that were made during the process. Finally, we will wrap up with a look at the future directions we recommend for continued improvement and expansion. So let's talk about the background. In many real-world team environments, project management tools can be either too bloated and complex or fragmented and inefficient. So for small and mid-sized teams, that often means spending more time managing the tools than managing the project. You either get lost in the maze of menus and configurations or struggle with tools that don't really talk to each other. This leads to frustration, reduced productivity, and sometimes miscommunication between team members. This is exactly the scenario illustrated here, where a developer is overwhelmed by clutter, both literally and digitally. So after identifying those pain points, our goal became very clear, is that to create a tool that is lightweight, streamlined, and can actively assist the user. A platform that feels intuitive, but still powerful and flexible enough for real teamwork. And that is exactly what TechScrum aims to be. So how does TechScrum deliver on that vision? We have defined three core concepts to be the foundation of our platform. The first is the product usability. We believe that great tools should work with you, not against you. That is why TechScrum is built for real-time responsiveness. Every task update is instant, so teams stay on the same page at all times. And then is the intelligence assistance. To reduce the manual work and improve daily flow, we integrated an UI assistant directly into the platform. It helps with tracking, planning, and even responding, making collaboration smarter and smoother. And then is the commercialization support. Finally, we know teams need payment features at a certain point, so we've integrated Stripe to support subscription and extensible payment flows, making TechScrum a scalable solution. So with that vision in mind, let's take a look at what we set out to achieve in this iteration. We translated those core ideas into 4 specific goals. Product usability. We focus on implementing real-time broadcasting to make user interaction smoother and more immediate. And then it's intelligence. We introduced an AI-powered text refinement feature, helping users generate clear and more consistent content effortlessly. And then commercialization. We made our Stripe integration production ready, enabling real-world transactions and prepare for the product for monetization. Lastly, function and test optimization. We improved the system testability and the stability, laying the foundation for long-term reliability and maintainability. Each of those goals directly support to the core values we introduced earlier, and they form the scope of our development this cycle. After defining our goals, let's talk about how they were done. The first one is the real-time broadcasting. This feature solves a major pain point in many management tools, that is, the information not being up to date. Without real-time updates, user may need to refresh page manually, risk working with outdated data, and sometimes even make decisions based on task that is already obsolete. This can easily lead to conflicting task states, repeating actions, and overall a poor user experience. So, with real-time broadcasting, TechScrum keeps everyone on the same page at all times. Here, we have a diagram illustrating the real-time update workflow in TechScrum. At the beginning, both user A and user B connect to a shared room via a WebSocket. This room is identified by a unique key, which is typically responding to something like Spring ID or project ID. This is allow users to work on the same context to stay in sync. Now, when user A update an item, for example, editing a task, the change is first sent to the backend through an API call, and the backend then writes the update to the database. Once the database confirmed the updates was successful, the server emits an item updated event to the room that both users are connected to. Because user B is already listening to the same room, they immediately receive the event and trigger the UI refresh or the data refresh on their side. This flow ensures that all users are working with the most up-to-date data without needing to refresh the page manually. It significantly improves the usability of the product and supports smooth real-time collaboration, especially in a fast-paced, team-based environment. Now let's talk about some of the challenges we faced when implementing real-time broadcasting and how we tackled them. So first, we needed a way to distinguish between different user groups. Since multiple users could be collaborating in different contexts, like retrospective or backlog, we decided to use a unique key based on the context. For example, Spring ID for the retro board or project ID for the backlog. This way, user only join the room that matches the pages they are currently on. And second, we had to make sure we don't create duplicate socket connections. To solve this, we use a front-end state called current selected room ID to track which room the user is currently connected to. Every time the user switches sprints or boards, we close the previous connection before opening a new one. So lastly, we focus on security. We applied strict CORS policies to only allow connections from specific domains and HTTP methods. This helps prevent unauthorized access and keep our system secure. So let's take a look at the demo video for the real-time broadcasting. Now let's take a look at how real-time broadcasting works on RetroBoard. First, I'm going to create a new test item under the well-done column. As soon as I click submit, the new item instantly appears for all other users who are viewing the same board. Next, I will drag this item to the improve column. You can see that the changes is reflected in real time across all other clients. Again, no need to refresh the page. And finally, once it gets deleted, it disappears.
Hello Kevin，你这边的声音有点小，弹幕展示的声音完全听不清楚在讲什么。
Creating update. 哦，
对，你要调整一下声音。
这一部分我不太清楚怎么调声音啊，这个地方。我稍微看一下。哦，抱歉，我这里没有调声音的这个选项，我这里。这样吧，我那个什么，我自己说一下。
对你话外音一下，对，
嗯。
好，谢谢。
Okay, so here, as we can see that we've opened two windows here, and now we can try to create one test ticket. Now let's take a look at how real-time broadcasting works on RetroBoard. First, I'm going to create a new test item under the well-done column. As soon as I click submit, the new item instantly appears for all other users who are viewing the same board. And then we can drag the test item to the other column, and you can see that the other window that the user is connected to instantly show the changed item. Again, no need to refresh page. And finally, and also we can try to delete item, and you see that all the users connected to the same room have already shown the updated data. All these actions, creating, updating, and deleting. Okay, so now let's move on to our Stripe payment integration, which was officially launched during this iteration. This feature was initially developed by our teammates in early stages. Our job this time was to finalize, refine, and bring life to the production environment. First, we completed the deployment process. Stripe integration is now fully functional and available for real user access in production. Next, we refactored the initialization script. There were some mismatches between the testing and the production setups, so we streamlined the environments, variables, and made sure both modes now running smoothly with a consistent default setup. Finally, we verified everything using the Stripe dashboard. Test pavement went through successfully, and the system is now ready to handle real user pavement.
Okay. Next, I'm going to talk about our AI-powered commitment and issue refiner. Now, why we developed this feature? During the development, we run into several pain points. First, when business analyzer creating the issue, the description might unclear and unstructured, which made it hard for developers to fully understand the task. So the second, there was no consistent writing style. So every description looked different and often caused confusion. And that is why we created this feature. When someone writes an issue descriptions, AI can instantly refine it into a well-structured format by giving a template. This helps reducing refusion and keeps the whole team on the same page. All right, let's move on to how it actually works behind the scenes. And we have deployed this feature as a serverless microservice using AWS Lambda because it's flexibility and maintainability. With Lambda, we can easily scale it, remove it if needed, remove it if needed, and while also reducing cost in the early stage. And the workflow is straightforward. You can see this picture. The front end send a request with an action to API gateway, which invokes the Lambda function. And Lambda then selects the right tools function called, we choose the Astropic API here, and using the function call, and receive a structured JSON response. Then it handles the response, removing unnecessary metadata and return the clear result to the front ends. And this architecture gives us a clear separation of concerns, better scalability, and faster integration for future changes without impacting the core application. All right, during development of this feature, we faced some key challenges. First, our initial approach for invoking AI was through plain text integration. However, the response were unpredictable. We found the response were unpredictable and difficult to parse, which makes it hard to integrate into our workflow. So to solve this, we adopted the function calls. The challenges this part. We faced some challenges. So the first, our initial approach for invoking AI was through the plain text integration. However, the response were unpredictable and difficult to parse, and which is hard to integrate into our workflow. So to solve this, we adopt the function call mechanism, which allow us to receive structured and reliable outputs from the AI. And second, we originally tried to integrate the AI feature directly into our main service. But as the system grows, this led to maintainability and coupling issue. So to address this, we migrate the AI logic to AWS Lambda as a separate microservice. Let's decouple the feature and also give us a better cost efficiency and scalability. So in the early stage, this is for the early stage. So and finally, when we select the AI module, we face a trade-off. For example, DeepSeek. At first we are planning to use the DeepSeek. It was very cheap, but it's often delay and lag pressures. While OpenAI was more accurate, but it comes with higher cost. After testing multiple options, we decide on Astropic AI API for the best balance between this cost accuracy and response speed. All right, next, I will walk you through a quick demo to showcase the feature in the action. Okay, so you can see we are editing the issue. And yeah, we just type some issue description in the casual and unstructured way. Yeah, like this. And we click this button to ask AI to rewrite the description. Yeah, you can see it shows up with a nice structured format. With like this field, limitation, technology detail, and infection-related function. Yeah, and for the comment section, the same goes for the comments section. When a user type in the comments and click the button, the AI will refine it and rewrite it to make it clearer. Yeah, like this. Of course, the promote can still be refined, but since this is just an MVP version, so we haven't make it as make this very perfect yet. Yeah, this is a demo.
Okay, thank you, Shelton. Let's take a look at an optimization we made to the backlog page. So here we introduce an auto detection of outstanding ticket when a sprint is marked as complete. This means if there are any tickets still in a non-done state, like to do or in progress, the system will automatically detect them to prevent silence data lost. As shown in the video on the left, when a user tries to complete a sprint that still has unfinished tickets, a confirmation dialog will appear. Shelton, do you mind to play the left video?
Oh, sure. Yeah.
You can just click on the button in the middle of the video. So this means if there are any tickets still in a non-done state, the ticket here the system will automatically detect them and prevent silent data lost. And then, as shown in the video on the right, when the current sprint is completed and there are no other active or upcoming sprints, the system will automatically move all unfinished tickets back to the backlog. Their status will also be updated accordingly, ensuring that nothing gets lost and the team can clearly pick them up in the next planning cycle. In addition to the optimization, we also focus on improving system stability through key bug fixes. First, we resolve a ticket status change issue caused by inconsistencies between the interface and the data structure. Second, we fix a login failure that occurred when user entered their email with inconsistent letter casing. And lastly, we made ongoing improvement to our test framework, ensuring future updates can be tested more effectively and reliably.
Okay, next, yeah, thanks, Kevin. Next, I'm going to talk about the future plan. First of all, for our AI-powered assistant function, so we are planning to enhance security and compliance. Compliance. Right now, our function works well, but So to make sure to make it enterprise ready, we are going to add stronger validation layer to filter out any inappropriate data before it's reached to the user. Second, we want to integrate more tools and support multiple languages. Today, our AI works in a single context, but by introducing multi-tools integration and multi-language support, we will make it far more flexible and better suited for different teams and regions. Finally, we aim to improve contextual accuracy, and our current AI function works, but it can be better. To improve that, we are planning to bring in long chain so that we can better manage context, maintaining conversation history. And yeah, next is a real-time updating. So while our current broadcasting system works well, and we aim to further refine this by designing mechanism that prevents concurrency issues, especially in collaborative editing scenario. And then under the subscription plan, we plan to enhance our Stripe integration by introducing tier-based feature access. This means users on different subscription levels will be able to unlock different set of functionalities, allowing us to provide a more scalable and flexible product experience and deliver more precious results. Yeah, thank you for listening.